Now we're ready to look at graphs of functions. We said a function is a relation in which each element of the domain corresponds to exactly one element in the range, which basically said you cannot repeat the x values. When we look at graphs, we can use the vertical line test to determine if a graph is a function or not. A vertical line can intersect the graph of a function in at most one point. This again shows that each x value has only one y value. Let's look at an example. When we look at this graph, we can see the points 4, 4, and 4, -4. We have the same x value with two different y values. This means this is not a function. We can see that we can draw a vertical line through the graph and it intersects in 2 points. Anytime that happens, we say the graph is not a function. Take a look at this next graph. We could try to draw many vertical lines through this graph, but it would intersect the graph in 1 point. This says this graph is a function. If we look at non-vertical lines, we'll see that they're all functions. I could draw as many vertical lines as I want, and they're each going to intersect the graph at 1 point. Even if I make this a horizontal line, we see the same thing. Once we know what the graph of a function looks like, we want to be able to read values of the function. Reading values of functions are like reading graphs from a chart. If we take a look at this line graph that looks at the number of new customers, and I wanted to know the number of new customers in March, I would go to March on the graph and I would look up to the point on the graph which says 36. Think of this as input March, output 36. Same thing if I wanted to look at what happens in October, I would look at October on the graph and look up to the y value, which would be 65. We can use the same kind of reasoning to find the values of f of x seen in this graph. If I look at f of 0, I can see when x is 0, my y value is 3. When I look at x being -1, my y value is 0. When I look at x being -2, I can see the y value is -1. And when I look at x being -4, I can see the y value is 3. So I want you to think of this input x and output y. I'm kind of think of it when I read a function value, I'm given where to look, and then I say, what do I see? To graph a function, we can create a table of values and look for the shape of the graph. We're going to start with f of x equals 3x minus 5. I create a table where I put in the x values I want to use, then I calculate the y values using my function, and then I'll look at my point xy. So let's start easy. Let's use the x values of 0, 1, 2, and 3. F of 0 will be 3 times 0 minus 5, which is -5. So my first point is 0, -5. Then I'll calculate f of 1, which is 3 times 1 minus 5. 3 minus 5 is -2. F of 2 is 3 times 2 minus 5. 6 minus 5 is 1. I have the point 2, 1. Then f of 3 is 3 times 3 minus 5. 9 minus 5 is 4. So I have the point 3, 4. I take those numbers and I plot them on an xy coordinate system. We can see this is the graph of a line with slope of 3 and a y-intercept at -5. Let's graph f of x as x squared minus 3. Again, I'll make a table of values. This time I'm using x values -2, -1, 0, 1, and 2. F of -2 will be -2 squared minus 3. That's 4 minus 3, which is 1. That gives me the point -2, 1. F of -1 is -1 squared minus 3. 1 minus 3 is -2, so I have the point -1, -2. F of 0 is 0 squared minus 3. That's -3, so I have the point 0, -3. F of 1 is 1 squared minus 3. That gives me -2. That's the point 1, -2. And then f of 2 is 2 squared minus 3, which is 4 minus 3. That gives me 1. So my last point is 2, 1. Here's a summarized table, and then I plotted the points. So as we go, we're really connecting the dots and trying to find an overall shape. This shape looks like a U. The hard part is knowing which x values you should use to get the appropriate shape of the graph. As another example, I have f of x is -x squared plus 4. I'm going to use those same values of -2, -1, 0, 1, and 2. I have f of -2 is -2 squared plus 4. Having these double negatives means you really need to pay attention to order of operations. So I have -4 plus 4, which is 0. starting with negative 2, 0. F of negative 1 is negative 1 squared plus 4. Negative 1 plus 4 is 3, so I have the point negative 1, 3. F of 0 gives me negative 0 squared plus 4, which is 4. There's 0, 4. F of 1 is negative 1 squared plus 4, which is a positive 3. And then F of 2 is negative 2 squared plus 4, which gives me 0. Just like before, I start by plotting my points, and then I'm looking for that shape, which looks like an upside down U. I think it's important to say that graphing functions is not trivial. There are many types of functions and shapes of graphs. It will help to remember f of x equals mx plus b is a line. A function of the form f of x is ax squared plus bx plus c looks like a u. And if I have f of x is negative ax squared plus bx plus c, then the u is going to flip upside down. As you're graphing in this beginning stage, you're usually given the x values to plug into the table, but you do need to know the shape that you're going to get when you graph, so this will be really handy to look back on as you're doing your homework. As you take more math classes, you'll continue to learn about graphs of functions, so for now I want you to think of this as a discovery phase. Get used to graphing points, reading functions, and making connections with the concepts.